A system of linear equations is two or more equations that you graph on the same coordinate plane or that you solve simultaneously. The solutions are the ordered pairs, the x and y combinations that work for all of the equations in the system. So if an ordered pair is a solution, you can plug the x and y value into all of the equations and it will make a true statement for all of those equations. If we were to graph systems, there are three specific types of systems. Type A is a system where the two lines meet at one point. This means there is one solution. And that solution, if we counted, is the ordered pair 1, 2. The x value 1, y value 2. B is another type of system. How would you describe the lines in type B? Parallel. Do parallel lines ever meet or cross each other? So the solution is where the two lines meet. So if the two lines never meet, what does that mean for the system? No solutions. Now, algebraically, how would this look? When we solve our system, if all of the variables go away, and so let's write all of the variables cancel, and we're left with a false statement. And we'll see this when we start working on the examples. If all of the variables cancel out, eliminate, go away, whatever, and we're left with a false statement, like negative 12 equals 5. Negative 12 doesn't equal 5, so there are no solutions. In type C, you can't see the blue line, but the blue line exists right underneath the red line. So the two lines are basically the same. It is the same line. This would be many solutions, because every point on this line is a solution to both equations. And since there's an infinite number of points on the line, there's an infinite number of possible solutions. Algebraically, if your variables cancel, and you're left with a true statement, then you have many solutions. Like you end up with 0 equals 0 or 5 equals 5. If that's true, many solutions. First thing we're going to do is check to see whether these ordered pairs happen to be solutions to these systems. So your first number is your x, your second number is your y. We're going to plug 6 and negative 1 into both equations. Use your calculators to help you, use parentheses to help you. So 4 times 6 minus a negative 1 equals 25. 4 times 6 is 24. Minus a negative 1 is plus 1. Does 24 plus 1 equal 25? Yes. So far, so good. Now let's try the second equation. Negative 3 times 6 minus 2 times negative 1 equals negative 16. Does negative 18 plus 2 equal negative 16? Yes. So 6, negative 1 is a solution. I would like you to try B on your own. This system is kind of nice because it tells you right away that you can stop wasting your time. Negative 4 plus 8 is definitely not 52. So that means negative 2, negative 8 is not a solution. If it doesn't work on the first equation, don't waste your time with the others. It's not going to work. To solve systems algebraically, there's two methods that we're going to learn about. There's the substitution method and the elimination method. The substitution method is all about substituting, which is why it's called the substitution method. The substitution method says that first we need to solve one of the equations for one of its variables, and likely the system is already set up in that way. So notice x equals negative 2y plus 2. Because x equals negative 2y plus 2, think of x and negative 2y plus 2 as quarterbacks on a football team. X gets injured, tears his ACL, so we're going to take x out, and we're going to put negative 2y plus 2 in his place. So 3, instead of that x, we're going to put in negative 2y plus 2, and then finish your equation. Plus 4y equals negative 4. You can't solve an equation that has more than one variable in it, so the goal here is to get all of the same variable in one equation so that we can then solve for that variable. What would you do next? Multiply the 3, distribute. So we have negative 6y plus 6 plus 4y equals negative 4. This is a place where a lot of people make a mistake. Notice that negative 6y and 4y are on the same side, so you simply combine them to get negative 2y plus 6 equals negative 4. And hopefully that is an equation that you can practically solve in your sleep by now. So we subtract 6 on both sides. Negative 2y equals negative 10. Divide both sides by negative 2. Y equals 5. Okay, don't forget about step 3. Substitute the value from step 2. So we need to take this y equals 5 and substitute it into one of our original equations or one of our revised equations and solve. So I'm going to pick this equation. If I want to know what x equals, it'd be really helpful to use the equation that says x equals. And this time, instead of the y, we're going to put in 5. X equals negative 8. Please write your answer as an ordered pair. Parentheses, your x value, comma, your y value, close your parentheses. So look at example 2, and you want to be strategically lazy. You don't want to do a ton of work that you don't have to do. So when I look at number 2, I think, if I just added y to both sides, I'd have x equals, and that's not a whole lot of work. So I'm going to add y to both sides to make this x equals y plus 13. Now, if x equals y plus 13, I can take the x out of the other equation and put the y plus 13 in its place. Parentheses are your friend, so 2 parentheses y plus 13 plus 2y equals 10. Distribute, combine like terms, and solve. Distribute your 2 into the parentheses. Combine the 2y and the 2y to get 4y. Subtract 26. Divide by 4. You should get y equals negative 4. Now, you've got some options. You can plug negative 4 into the original first equation, the original second equation, or your revised first equation. I would pick your revised first equation if I were you, because it's going to be easier to get your answer. So x equals negative 4 plus 13. What is negative 4 plus 13? That's right, it's 9. So our solution is 9, negative 4. You are not done until you have written your answer as an ordered pair with the x first and the y second. The problem with number 3, again, we don't have x equals or y equals. Y is the only variable that I see by itself, so my goal is going to be to get this y by itself. And the first thing that I have to do is subtract 3x from both sides. That would give me negative y equals negative 3x plus 4. So if you need to see that, we're subtracting 3x from this side and subtracting 3x from this side. But we don't want negative y equals, we want y equals. So we need to divide everything by negative 1 or simply flip everything to the opposite. So y equals positive 3x minus 4. That's dividing everything by negative 1. This example is a little bit different than 1 and 2 because in number 1 and 2 we had x equals and now we have y equals. So 3x minus 4 is going to go in place of the y. Negative 9x plus 3 parentheses. Instead of your y, we are putting in 3x minus 4 equals negative 12. Distribute. We get negative 9x plus 9x minus 12 equals negative 12. What happens? Negative 9x and 9x cancel each other out, leaving us with negative 12 equals negative 12. Is that a true statement or a false statement? If all of your variables eliminate, and you're left with a true statement, that means many solutions. All right, I'd like you to start number 4 on your own, and then we'll talk about what your answer might mean. Okay, so I'm going to add 2x to both sides. That will give me y equals 2x plus 6. Now the 2x plus 6 is going to get put in place of the y. So 4x minus 2 instead of the y, 2x plus 6 in parentheses equals 5. Distribute. We end up with 4x minus 12 equals 5. 4x minus 4x, those cancel each other out. Negative 12 equals 5. Is that a true statement or a false statement? And if you get a false statement, that means no solutions.